So when you look out on the highway and see one of those massive 18-wheelers cruising the interstate, you likely see logistics, right? Cargo, simple freight movement.
Mm-hmm. That's the common picture.
But if you want to be really well-informed about modern commerce, you kind of need to update that image. You should actually be visualizing a sophisticated, highly mobile data center.
That's a great way to put it.
And this deep dive is all about that quiet technology revolution that has fundamentally transformed modern trucking. The word for it, telematics.
And that transformation, it's profound. For decades, telematics was basically simple GPS, a blinking dot on a screen.
Right? Just answering, where is my truck right now?
Exactly. Pretty rudimentary location data. Our goal here is really to unpack how that evolved into this incredibly complex, predictive, intelligent platform. It's like the true nervous system of the whole trucking operation now.
Making things smarter, safer.
And critically hyper-efficient. This isn't future tech, this is today.
Yeah, the shift in operational focus is just staggering when you think about it.
Yeah.
Old systems, pure geography.
Where?
Exactly. Now it's about almost like biological and mechanical health, driver efficiency, even predicting resource needs.
Uh-huh. Answering much bigger questions.
Like how healthy is the engine right now? Or maybe more importantly, when should maintenance happen before some catastrophic breakdown?
It's those sophisticated health checks, that are driving probably the most dramatic financial change. We should definitely start with predictive maintenance, that ability to plan repairs potentially months ahead.
I think sometimes we forget just how disruptive fleet maintenance used to be. Before these kinds of systems, it was totally reactive, wasn't it?
Oh, completely. It was pure guesswork built on, averages. You either followed these generic, often really conservative mileage schedules.
Meaning you pay for parts you don't even need yet.
Precisely. Or you just waited. Waited for that disastrous, unplanned roadside breakdown. And that unplanned event is the industry killer. Seriously.
It's not just a tow truck fee, is it?
Not even close. Studies show an unexpected breakdown can easily cost a fleet upwards of, say, $15,000 to $20,000, sometimes more.
Wow. How does it get that high?
Well, you factor in the crazy high cost of emergency labor, parts maybe hundreds of miles from a main service bay, then the lost driver hours, not to mention the steep penalties if the delivery is late.
Okay, yeah. That's the scale of the financial hole we're talking about. Puts it in perspective.
Definitely.
That kind of potential loss makes the case for predictive tech pretty compelling. But how reliable are these predictions, really? It can't just be like a simple pressure reading changing.
No, it's far beyond that.
When you say predictive, what's actually going on under the hood, so to speak?
It's about synthesizing hundreds of data streams, things flowing every second through sensors on board the truck, oil pressure, engine temp, filter health, brake wear, tire condition, you name it.
Okay, lots of raw data.
But the prediction part. That relies on sophisticated machine learning models. These algorithms are trained on years, literally years of historical failure data.
Tailored to that specific truck model.
Exactly. Specific to the make and model of that engine, that transmission. They identify these incredibly subtle patterns in how things degrade over time. Patterns that, honestly, no human mechanic, no matter how skilled, could possibly spot just doing a routine inspection.
So instead of just waiting for the check engine light, the algorithm spots some tiny anomaly in that data stream.
Right. And the output isn't vague. The source material had a fantastic example. The fleet manager doesn't just get a generic alert like check engine.
No. What do they get?
They receive a highly specific, actionable prediction. Something like truck number 57's battery health is declining. We predict a 90% chance of failure within the next 30 days. Schedule replacement at the next depot stop.
That's incredibly specific. Actionable is the word.
It completely changes the whole maintenance workflow, doesn't it? Fleet managers are now empowered to plan those repairs, schedule them conveniently during planned downtime.
Like when the truck is back at the main depot anyway, maybe for a driver change or a rest period.
Exactly. You schedule repairs proactively instead of just reacting to failures. This ability, it radically reduces unexpected downtime, and it completely eliminates those sky-high emergency repair bills.
So it's basically a real-time digital health tracker for the entire vehicle, the whole asset.
Precisely. A health tracker for the truck itself.
Okay, and speaking of tracking assets and costs, when we look at operational expenses, we absolutely have to talk about fuel optimization.
Oh, yeah.
This is where those, small, quiet efficiencies start translating into massive structural savings for these trucking fleets.
Absolutely. Fuel is easily the largest and often the most volatile operational expense for any trucking company. It fluctuates constantly.
So the savings must add up quickly.
They really do. When you look at the economics, even just a 1 or 2% improvement in fuel economy across a large fleet, trucks running high mileage, that can translate into thousands of dollars saved per truck per year.
And millions across the whole business, potentially.
Yeah, easily millions. It's a huge lever.
So what exactly does this new nervous system track to achieve that level of saving? It's got to be much more than just measuring miles per gallon.
Oh, way more. It's extremely detailed behavioral and situational monitoring, often correlating what the truck is doing internally with external factors, like weather or traffic.
Okay, like what specifically?
Well, for starters, modern systems track excessive idling time at stops. That's just pure wasted fuel.
Rationally burning diesel going nowhere.
Exactly. But they also map driver acceleration patterns, hard braking events. They factor in real-time route specifics, things like the incline of the road ahead, known traffic delays from other data sources.
Yeah, mechanically.
Mechanically, they're constantly checking things like tire pressure under inflation, kills fuel economy, and engine load, trying to minimize it when possible through gear suggestions or route choices.
Right. So this deep analysis then feeds back into, what, two crucial areas?
Pretty much. First, it informs the dispatcher. They can see the data and maybe suggest a route that's slightly longer in miles but avoids a really steep mountain pass.
Resulting in a net fuel saving, even if it's a few miles further.
Correct. And second, maybe even more importantly, for long-term improvement, it provides a completely objective metric for driver efficiency.
How so?
Well, they can identify, say, two drivers, both operating the same truck model, similar routes, similar loads, but the data shows driver A is consistently maybe 4% more fuel efficient than driver B.
Okay. So it moves beyond just general fleet averages.
Exactly. It moves the fleet from a general cost picture to a precise, measurable one, driver by driver, route by route. This data lets the company reward top-performing drivers for being efficient.
Or provide focused coaching to others who might need it.
Right. Shifting the focus from just meeting the delivery deadline to operating with, well, hyper-efficiency, both time and fuel.
That concept, though, measuring human behavior, that brings us to what was probably the trickiest hurdle for getting this technology widely adopted, right? That inherent tension between constant machine monitoring and the driver behind the wheel.
That's absolutely right. When this tech first started rolling out more widely, it was often perceived, quite frankly, as purely punitive surveillance. Big brother in the cab.
Yeah, I can see that.
Yeah.
Drivers, understandably, felt a high degree of mistrust, maybe anxiety.
Definitely. Trucking is already a pretty high-stress, often isolating job. Feeling like you're constantly being watched for mistakes, well, that doesn't exactly foster loyalty or high morale, does it?
No, it really doesn't. But the source material talks about a pretty dramatic shift in how fleet managers use the data now. The question became, how do you track key safety metrics? Things like speeding, hard braking, rapid acceleration without destroying morale.
Right. How did the industry pivot? How did it go from being seen as a punitive tool to more of a supportive coaching mechanism?
That was the key.
The essential shift really came from adding context and ensuring transparency. It moved away from just, generating a report saying you braked hard at this location at this time, which feels accusatory.
Okay, so what replaced that?
Using the telematics data paired directly with dash cam footage. That was crucial. So if a sudden hard braking event is registered by the system,
The manager doesn't just see the data point.
no, they review the video clip from the dash cam to understand the real situation. Was the driver being aggressive? Or did a car suddenly cut them off, forcing a rapid defensive maneuver? The context is everything.
I see. So the data points themselves, the hard braking, the sharp cornering, the speeding, they're no longer just automatic evidence of guilt.
Exactly. They become objective indicators of specific situations that maybe warrant a review and potentially some coaching, not punishment.
But it becomes a conversation starter.
Precisely. Managers use this highly personalized data, often with the video, to sit down with the driver and review specific driving segments. Hey, let's look at this near miss, or let's see why fuel consumption spiked on this leg.
Allowing them to coach safer, more efficient maneuvers based on actual real-world scenarios the driver just experienced.
You got it.
Yeah.
And this collaborative approach, when done right, Demonstrably improves driver skill, reduces accident frequency significantly.
Which must help the fleet's bottom line, too.
Oh, hugely. It helps the fleet drastically reduce its insurance costs, thanks to having a much cleaner accident profile. It's really a classic example of how technology adoption can improve both the bottom line and the worker environment, but only if it's implemented thoughtfully, with buy-in.
That makes sense. So that collaboration, linking different operational areas, vehicle health, fuel efficiency, driver behavior, that brings us neatly to the final section, the power of synthesis. What happens when you combine all three of those data buckets into, say, one integrated dashboard?
It essentially eliminates guesswork entirely. Fleet management moves from being like a collection of separate departments, dispatch over here, maintenance over there, HR dealing with drivers, to one unified precision operation.
Everything talking to everything else.
Yeah, right. Think about the old way they decided when to retire a truck. Replacement schedules were often based on some arbitrary milestone, right? Like, okay, this truck hit 500,000 miles, time to replace it.
Just because that's what the fleet generally did.
Yeah, kind of a rule of thumb.
That seems incredibly inefficient, though, given that two trucks could hit that same mileage mark having lived completely different mechanical lives. One babied, one run hard.
Exactly. Totally inefficient. Now, with integrated telematics, they can run an algorithm. It factors in the actual historical performance data of that specific truck's engine.
Pulling in the maintenance history triggered by those predictive alerts we talked about?
Yes. And maybe even the fuel efficiency scores of the different drivers who operated it over its life. The system might calculate that, say, truck #88 has been driven so efficiently and maintained so proactively based on alerts.
That its useful economic life is actually much longer.
Could be 150,000 miles longer than truck #89, which maybe ran heavier loads more often and saw frequent hard-braking events indicating more stress on the drivetrain.
Wow. That completely changes capital expenditure decisions then. It allows a company to plan optimal replacement cycles based on empirical, real-world performance and wear.
Not just general age or a rough mileage number.
That's the holistic power you're talking about.
That's it. It enables this hyper-proactive resource allocation, like getting replacement parts ordered before they're critically needed, minimizing that costly downtime. It ensures every route is evaluated for optimal fuel use and timely delivery.
And you mentioned sustainability, too.
Critically, yes. This integration empowers fleets to actually accurately measure and then actively lower their emissions, which helps them meet increasingly stringent sustainability goals. That's becoming a major factor in corporate responsibility and even in winning contracts.
Right. This brings us back perfectly to the core idea from the source material. While, the media loves to focus on the flashy, futuristic stuff like fully autonomous trucks or drone deliveries.
Yeah, the sci-fi headlines.
The source points out that the real impactful revolution, the one happening right now, is happening quietly. It's the widespread adoption of this smart telematics.
Making the existing fleet exponentially better.
Exactly. Making the fleet you see on the road today smarter, safer, and vastly more efficient without needing any big fanfare.
It's the evolution of a foundational technology, but one that now touches every single facet of the business right now. The drivers, the mechanics, the dispatchers, inventory managers, the owners, everyone's job is impacted.
So to summarize the definition shift we've really explored here, telematics isn't just that blinking dot on a map anymore.
Not at all. It's become this complex nervous system. It connects the machines, the drivers, the managers, the back office. This entire network transforms raw, often overwhelming amounts of information
Into intelligent, actionable, operational decisions.
Right. Decisions that allow fleets to be much more agile, hyper-efficient, cost-effective, and ultimately more sustainable businesses.
That is a powerful and, I think, crucial distinction for people to understand. So the next time you observe a big rig on the highway, you really should appreciate that it's acting as this conduit, moving massive amounts of data just as much as it's moving freight, constantly feeding intelligence back to headquarters.
A data center on wheels.
Exactly. So given how profoundly this deep dive shows the integration of this kind of nervous system approach in logistics and transport, here's a thought to leave you with. What major foundational industry do you think is next? Which sector is poised to fully automate its operational efficiency and critical decision-making using similar integrated telematics? Something to consider as you see this quiet data revolution unfolding all around you.